when you are a little bit acquainted with radio theory, oscillation, transportation of electromagnetic energy through the air, this will absolutely be not new. So this is the title of the video: wireless energy transport, electromagnetic resonance or electromagnetic influence, oscillator that works on its natural oscillation frequency, etc. In fact, the circuit was already published, but I did some small adaptations, and apart from that, I don't pretend to know a lot of this. I only know it in relation to practical experiments, no calculations. I know the physics principles and nothing more. So don't expect too much, but it could be interesting for everyone interested in these issues. This is again that blocking oscillator that I published earlier. I've done some different things. I have now made a separate coil and connected to that coil a LED, 250 windings, very thin wire. The primary coil consists of 50 windings, as the backcoupling coil here is coupled back to the base of the Darlington, and here 25 windings, both 0.4 millimeter wire, and furthermore the whole circuit is the same. And here the used transistors, 2 ferrite rods. Now you can see them here. This is one and this is the other one, and here on this rod the primary winding is wound. So what can we see regarding this subject? I put out the light, put on the scope and the counter to show where it works. Well, let me at first show where it works. It works on 157 Hertz. This is the waveform, very sloppy waveform. Has everything to do with the type of oscillator, the blocking oscillator. It often has very sloppy waveforms, and their waveforms change enormous when the voltage is changed and when the bias is changed. By changing the voltage, the bias is changed. And of course we have that bias potentiometer. Via that we can also change the bias, but anyway. So I put out all the lights. Hope it's still visible. Here we have the secondary coil with a hole in it. I can stick that into, so I can stick it upon the primary ferrite rod, but also I can stick it on that secondary rod. Let's first see what happens when we stick it on that primary rod. So you can see that the LED lights up. And when I stick it further, closer to the primary coil, it gets more fierce. So that means that the electromagnetic coupling gets better. And when I take it farther away from that primary, the light stops. Do it again. Fierce light. So that means that when this pickup coil here is moved farther away from the oscillator coil, it's warm, by the way, I can feel it, the coupling is less and less energy is transported. Say, in other words, the secondary coil cannot pick up a lot of energy. Perhaps that's a better way to say it. Because the magnetic field here around that ferrite rod is strong, but we remove now the pickup coil out of that magnetic field on 137 Hertz. So that's one demo to show how that works. The other demo is this, and now I'm going to show this. Here I stick the ferrite rod into that 250 windings coil and bring that coil close to the transmitter coil. Now I pick up the camera to show all the different effects. The primary core is now in line with the secondary core, and when I move it away again, you will see that the light gets smaller and smaller. Well, I took out the cord. That was not the idea. So here we see it again. We move it away, and the electromagnetic energy sent through the air is not completely picked up by the pickup coil. And there is a formula for that, and you can directly see that the energy that is strayed out by the primary diminishes very quickly when the distance between the transmitter here and the receiver here is small. So there is an enormous energy loss here. At least there is no energy loss here, but I mean that the energy that is picked up by the high voltage coil gets very quickly away, at least in that secondary coil, in that pickup coil. There's also the idea of the orientation of the two coils. Now they are in line here, and it is quite fierce, but when I turn this, the pickup coil moves in a certain way out of that magnetic field, high frequency magnetic field, and like I told, on its self oscillation, and now the energy that is taken up is minimal. So when I move it away, it has an effect. When I change the orientation of the core, it has an effect. But this is a little bit strange. But of course there must be a good scientific explanation for that. When one is horizontal and one is vertical, and the cores touch each other, there is still a good amount of energy transported through the air. So what's the maximum distance where this LED still lights up? Well, let's see. It's approximately here, and it is, say, 18 centimeters or so. When we are talking about radio coils, there's a lot of theory about it. Often you see when in a radio circuit coils must couple on its best way. The cores are say in the same position compared to each other. So in this example, both vertical. And again, when I move it away, and in radio theory, this is called that the coupling gets more and more critical. And when you study this with the oscilloscope and look at the bandwidth, you will see that the bandwidth in general, I don't know that for sure in this case, but anyway, when it is a radio coil, the bandwidth gets sharper, so the frequency gets more precise. But perhaps this works on, this is not completely true anyway, thanks. This is 150 Hertz at this waveform, but anyway, there are many videos on my YouTube channel where that is say explained much better, and this is say only a first idea. Again, I cannot stress that enough. It's a kind of silly experiment where I want to show some principles for people interested in this issue, working with Bedini circuits, etc., etc. So here again that effect. You can see when I do it quick. You can also see the influence of the magnetic field. You can make it visible in this way. So here we have a good pickup of the energy. Here we have a good pickup of the energy, and also here. Seems a little bit strange to me, but anyway, there are formulas, there is scientific literature about what is exactly happening. So, thanks for watching. Hope it was a little bit interesting. Kind of experiment where essential properties are showed. Essential properties of the things that I'm talking about. The schematic again, easy to make schematic. When it does not want to oscillate, reverse on the here, this coil, the backcoupling coil, reverse the X and the A. So when it doesn't oscillate, reverse this, then it will surely oscillate. You can set the bias a little bit. Perhaps I can give a demo of that effect. Oh, well, so here again, now there's good energy transport. Change the bias, so it has an effect on the transportation of energy. And I turn the bias back to a moment where it doesn't no longer work, where the oscillator stops. And there's here tiny movement on that potentiometer where it is somewhat better. The output of energy. Again, thanks for watching. Hope it was a little bit interesting.